I've created a new type of receiver for combat robotics, the ESP Rx Nano. This receiver will be a cheaper alternative compared to typical radio transmitter systems and also gives robots a competitive advantage against their opponents. This receiver lets you use any old video game controller to drive your robot instead of buying a radio transmitter. It also allows the robot to automatically invert the drive controls when flipped upside down, which solves a long-standing problem in the combat robot world. This new receiver was installed in my 150-gram wedge robot, Phalanx, for a test run at the latest UCR event. Phalanx performed well, achieving its first ever win with the new receiver installed. Phalanx did suffer some connection issues later on, but that was due to a direct hit to the receiver through Phalanx's thin armor. I wasn't too worried about that. All in all, I was happy with the tournament results. The ESP Rx Nano is a bit more hands-on than your typical receiver, so I'll walk you through how to get it working in your robot. First, you'll need to solder the ESP32 to the board. Make sure you put the USB-C port on the outside like so. The easiest way to solder these together is to use some header pins to line up the board and solder a couple of pads in the corners to keep it in place. Then remove the pins and solder the rest. For the output pins that go to your ESCs, you can use the 90-degree pins or use normal header pins, whichever works best for your robot. The last thing to do is to protect the board by adding heat shrink or electrical tape. To get the code running, the first thing you'll need to do is download the Arduino IDE from the Arduino website. Select the download version here and install it to your computer. With the Arduino IDE open, go to Tools, Boards Manager, search for ESP32, and install the ESP32 library by Espressif Systems. Next, go to the GitHub link in the description to get to all the code. Once here, click on this drop-down button, and if you know how to use GitHub, feel free to clone it. If not, you can click Download Zip and extract it to your computer. Once you've extracted the code, go into this folder and open up the ESP Rx Nano Arduino file with the compiler. Once this file is open, you'll notice that all these other tabs appear. The next thing to do is to plug your receiver into your computer with the USB-C cable. If your board has problems where it seems to be connecting and disconnecting from your computer every 2 seconds, press and hold the boot button with one finger and press the reset button with the other. These are the small buttons next to the USB-C connector on the board. This will put it into download mode and it will be ready to receive code. When it does, go to your board selector and search for the Nolojo ESP32C3 Super Mini. Click this and up here will show a port. Click on that and hit OK to select your board. Once your board is plugged in, go to Tools and open the Serial Monitor tool. I'm on vacation, so I don't have my board with me, but normally there will be a drop-down menu to select your baud rate. You'll want to select 115200 as your baud rate. Once you do, messages from the board will start appearing here. Before uploading code for the first time to your robot, we first need to change 2 files in the code. Close the Arduino IDE for now and go to the source file. Go under this folder and we'll need to create a file called secrets.h. I've included an example here for us to use. Take secretsexample.h and let's rename it to secrets.h. Then open it again in the Arduino IDE. Once the Arduino IDE starts up again, go to secrets.h and you're going to put in a Wi-Fi password and SSID for the Nano. I like to name it my bot's name, for example Phalanx. Put in a Wi-Fi password for yourself here. You can leave this as 1234 or put in a different pin if you'd like. We'll use this later. Once you've configured the Wi-Fi settings, go into the settings.h file. This is where you'll put in different things about your robot. For example, if you'd like to enable mixing for your drive controls, you can set this to true instead of false. For the flipped correction enabled, this is set to true by default. If you don't like this feature, you can turn it off. The most important one to get right is if your weapon is bidirectional. If you wish for your weapon to spin the other way when flipped upside down, and you have set your ESC to be bidirectional, then make sure to set this to true. Otherwise, keep it at false, and it will operate as a normal brushless weapon. If you would like to inverse any channel controls, you may do so here by switching these from false to true. And if you would like to put limits on your steering, forward and backward, or even limits on your weapon, you can do so over here. In order to put limits on these, the numbers must be between 0 and 1. Think of it as a percentage. If I want to change my steering limit, which I do on most of my robots, I could put it at 40% by setting this to 0.4. Once this is all done, hit Ctrl S to save. Go to the main file, ESP Rx Nano, and hit the upload button. It should start the upload process, and after a few minutes it should upload to your board. Once the code is uploaded, go to your serial monitor and try rotating the board upside down and right side up. You'll notice that it will tell you when it flips upside down and right side up. This is really fun to play with. If you ever want to make changes to the code and upload again, you actually don't have to plug it in with the USB-C every time. If you turn your robot on and connect to it as if it were a Wi-Fi service, it will pop up here with whatever name, and you can join with the password that you added. Once you connect to it, it should show up, your robot should show up as an unknown device that you can connect to, and you can actually upload all future code wirelessly. Now that your robot is all ready, the last thing to do is get your computer set up as the controller. To do this, we have to run a Python file that is in the folder of code. It is controller.py. If you've run Python files before, just open this in your favorite compiler or even with the terminal. Make sure your controller is plugged in before running it. This will automatically bind the controller to the robot and you can start driving. If you haven't set up Python before, it's very easy. I'll link some tutorials in the description on how to set up Python as well as an IDE to help you run Python files easily. Once you have your controller Python file running, all you need to do is join your robot's Wi-Fi network using the password that you set earlier and start the program with your controller plugged in. Note that the left trigger on your controller will enable or disable the robot entirely as an additional safety feature, so make sure to press that once before you try controlling your robot. Once it's connected and moving, you should be all good to go. Good luck, and please give me any feedback. Thank you.